That's the, yeah, I really like this one. It's clear. Okay.
Yeah.
So we're all underneath. This is just the North Star or something in the middle. It's not here in the middle of it. It's underneath. Okay. And basically, if you look at these angles here and place it, what I have is in a new moon, what happens is the sun is here, and the moon is in the sky with it, like the time and date pictures and that. It's doing it. So if you look at the sun every day goes around one time, and the moon does not go as quickly as the sun. It lags behind. So look at the moon. Here's the moon down here. And look at the moon in time as during the new moon, it is right here. 7 days later, on a half moon, it's here. Your sun is staying in this same position, and on this model, it's just, again, showing you how a month works. A full moon, the moon is up here. Your half moon, again, it's over here. And you're back to a new moon. If you look at the altitude, how the sun and the moon are getting lower in the model, and I'm going to do a camera in the middle in a minute to show this, is if you actually take a ball and shine a light on it, even though we're not saying that the sun is being shined on by here, we think it's an irradiation that is fluorescing the moon. So it is a fluorescent, not a visible light effect, but it's a fluorescent radiation effect that will work in the gemstones or in the minerals that we're working with. And so it's basically fluorescing a white during it when you see the full moon over here. And it's only the part of the moon that's exposed to like that direct sun radiation that is being illuminated. Okay, now with this in mind, so you'll see the different heights. So here's your new moon. Here's your crescenting as it's falling behind each day, 1 day, 2 day, 3 day, 4 day, 5 day, 6 day, 7. And then going away, around this way as it's waxing and getting bigger. I'm going to just show you how to mimic what the moon is doing. I do it laying on the bathroom floor because it's dark using a flashlight, but whatever works for you. You can actually, from underneath, play with light over the two and get fluorescent one against. I do it sometimes in the bathroom with fluorescent 1 to 2 and get the exact moon phases. And I'm going to switch it to camera and see if this makes sense to you.
The only thing I have a question on, the moon and the sun both go the same direction, though, correct? You seem to be showing.
Yes.
Okay.
They go in the same direction. I have the feedback, Sharon. Okay. They go in the same direction, but the moon travels slower than the moon travels at a slower pace than the sun, so it falls behind. So even though they're both going in this direction, when the sun makes it around 1 day, the moon is there. On the second day that the sun goes around, the
yeah, no, I know.
it's falling behind, and I do things dyslexic. So if I'm pointing to the dyslexic part of the line, forgive me, but it's falling behind just 1/7. So at the end of every day, it gets 1/7 like of the distance between here and here away.
Gotcha. But they're both going clockwise.
They're both going. Yes, they're both going clockwise.
Sorry, Tammy. Jaren is clarifying that where we have the moon's orbit, we've got those little brackets to demonstrate direction, but on the sun's orbit, there are no brackets. So I think he's verifying that the sun's orbit should also have those brackets, at least.
But the brackets are the wrong way.
Yeah.
They in the imagery reverse everything on us. And I'm probably even making it go around in the wrong way, too. It's the concept of the heights and where they are in position. I am a dyslexic person, but so I will do it backwards, but I have it right. If it forward or backwards, it's a visual concept.
And of course, eclipses will always happen when they are exactly on the same plane. And again,
no.
Oh, is that incorrect?
No, that you have that wrong. Your half moons will happen when they're on the same plane, because they're even, and I'll show you that. Your eclipses will happen when they're at the furthest distance from each other. Your new moon will happen here, and you'll have your eclipse, your moon going in front of the sun here, and your other eclipse is going to happen when the sun is here and the moon is here, and they're exact opposites, and that's the one that the sun going around. Oops. Oh, I'm sorry. I have a screen in this one here. Which screen? Okay, I'm on the correct screen. I am looking at 4 screens right now. It's a bit confusing.
Wow.
So, yeah, this picture does better reversed around because we know looking up in the sky, what did they go from west to east, and we know the direction. So disregard the arrows and the earth in this. This is meant to confuse you. Just look at the patterns and the heights.
What they've done here is, because they've placed a small globe Earth in the center which spins, you know, eastwards, they've said, look, so here's the Earth and this is a relative motion. No, the Earth doesn't spin, and those brackets should be pointing the other way. So it rises from the east, goes towards the west. Both the sun and the moon, both follow the same. Yeah.
But they are dancing like in this pattern where one gets higher and one gets, this is a moon, and they'll also write like a yearly, this is a monthly cycle that they will go high and low until this is a moon cycle, a new moon going around, you know, it falls behind. It's going around this way, but it's falling behind this way.
Yes,
does that make sense?
They are vacillating. That's the
right.
Vacillating. A bit like
right.
a symbol.
Perfect sense. I guess the big question is, what causes the lunar eclipse? That's the million-dollar question.
That is the million-dollar question. And what I have come up with, first of all, I'm going to show you the phases and the light, and then I'm going to hit that part, okay? Because I want to show you how it makes the phases, I think, for the people that haven't played flashlight and balls with us. Kirk, you have, I know.
Perfect.
All right. How do I share the camera? I'm going to sit right here. I just need flashlights and a ball.
You got to love this science. This is so awesome. I was just in the kitchen duct taping a camera to a ceiling fan, so I'm right there with you, Cammy. We got to do it.
Hello, everybody.
Hey, practical science. There you are.
Oh, is that scary seeing yourself in big on the screen? Okay, I'm going to let's just make me small and make Antonio bigger. Somebody make that. Perfect. That's perfect. Hi, Antonio. That's perfect.
Hey, how you doing?
Okay, I like actually seeing that screen. Can I just have it the way I... Okay, bring that up and then just make somebody I can talk to, put Antonio's face up there or something. Yeah. That's, no, I don't want to present that way. I'm sorry. Never mind. Present me. I didn't understand what I was doing. I thought it was my visual. Skype. Never mind. We'll do it this way. I'll get over it. Yes, I think we are.
Yeah, you're presenting. You're all set.
Yeah.
All right. So basically, for experiment time, and what you do is people need a flashlight and any kind of ball, if you can see this. Okay. Mm-hmm. And I don't have the right material or the right. Let me shift the things a little bit. But what you can do is you can look at sun and date and see what the phase is and where it would be on that alignment. And you'll find that if you move the light out of here, you're looking from you're down here in this model. You're under the ground. If I show the flashlight from where it is, I'll blind you out. So you have to do this at home. So you're coming out from underneath and looking like you're laying underneath it. In a new moon, the sun is higher and the bottom is dark. Is that clear?
Yeah.
That from where you would be seeing from underneath it, you have the sun is higher than this, and you do not. It's dark from underneath it.
So all you're seeing is darkness where the moon is. You know, right. The moon isn't sending any light down for you to see from the ground below.
Now, as it comes closer in angle and comes down from the bottom, you'll be able to lay on the floor and see your perfect crescents coming until you get to an even thing, which is your half moon. And from underneath here, you have your half moon. If you do it the other way, on the other side of the month, you have your other half moon. Mm-hmm. And as your full moon, the sun is radiating at, oops, it's not a perfect, I'm going to do this side here. Your full moon, what's happening is your sun is underneath, lower than it. It's actually shining up so you see the whole bottom of it. And again, it's hard to get the right angles while on camera, while looking at the screen. But so your full moon,
it's at the other end of that. So we have those rings. We have the moon on one extreme, the sun on the other extreme, but lower.
The sun is lower, so the sun is hitting this part, so you have your full moon. So this is your full moon, even though they're further apart. It's done by radiation, not by a little flashlight.
Yeah.
And so I don't have the right mechanism. I'm just giving you the look of it.
Right. Now, one thing I do want to say, guys, is this can also, for demonstration purposes only, we'll talk about the radiation and how the moon is fluorescing a little bit later. But it also works very much because Cami pushed this model for a long time on light only, light being reflected.
Yeah.
And we have since modified that, but for demonstration purposes, just assume that it is the sunlight entirely that's causing these phases, okay? And that would be a fair way to do it, Cami?
It's the radiation from the sun, not the visible light that's causing the fluorescent. Exactly.
But for now, we're just going to say it's the visible light, okay?
Well, I'm showing visible light doing it, yes.
Okay.
Yeah,
yes.
For illustration purposes. For illustration purposes, so we can see. You know, we can't see the radiation.
And just like I'm not showing you from underneath, but anybody can take any ball they have in any flashlight and make moon phases, and they can go and see where we are in time and date. And then they can draw how many lines, like how many days we're past the new moon, drop the moon there, hold it about the different angles, and you can actually make the different phases. So let me do this explanation again, that like if you're in London or in Denver or wherever you are, and your sun is over here at noon, it's always here, right? If it's nighttime, then the sun's here on the sun's path, and the moon is following here. In other words, the whole pattern is dancing. It's not a stationary pattern, but the sun will make it exactly one time around in 24 hours, and the moon will make it not quite all the way around. Right.
Yeah,
it will make it not quite as far, and it will lag each time by
50 minutes.
7 days. Yeah, 7 days right here.
Well, it's 50 minutes behind every day. So then 50 times the 27-day cycle equals exactly a day, or exactly a
how it works on the model, or how it works in reality, and the way that you see things is on it. It takes the moon will catch up with the sun again in about 28 days. Your moon cycle. Yeah, every 7 days you're going to go hitting 7 plus each 7 days here on the moon. So in 7 days the moon is falling behind this much. In 14 days this much. 21 days this much. 28 days you're back to ground zero again.
Yeah.
Is that
so we go from new moon to waxing quarter, full moon, waning quarter, new moon in this 4-weekly cycle. Yeah.
Exactly. Okay. Now you guys wanted to know about, so it's very obvious what happens is when you have, you call it the solar eclipse. The solar eclipse, because these patterns are like spirograph patterns that don't always align, when it hits most months, you don't have an eclipse, but if a piece of it if the rings overlap a little bit, you'll have a partial. And if these rings, they call it nodal points, and they say that they're aligned along the ecliptic. It's actually just much simpler than that. It's a straight up line above your head. If these circles are right directly underneath each other, you have your full eclipse. Wherever it happens in the cycle is where it does, right? Now your other eclipse, if you notice it, it's where your sun is here. Am I getting this right? Hold on, your other one. Your other eclipse is your sun and your moon further apart. They're furthest apart from each other, of course. And it happens with the full moon, so your sun's lower and your moon is higher, so it's backwards. Do you see that? Am I pointing to the screen right? Yeah.
Yeah.
And as the sun, and what's happening is, or what I see, there's some type of, because the sun is moving faster through its orbit here than the moon is, as it's hitting a space that's directly across the grid, through that time where they're just directly across from each other, I am thinking it's some type of Faraday effect or radiation dampening that you're only seeing is blocking out some of your visible light, and you're only getting, it's changing your light stream into a red. But the timing of the eclipse and the way that it seems to move backwards would point that it's affected to the sun's movement moving faster, hitting the moon on the wrong side, and it's some type of dampening field, or like again creating a dark object in the sky.
So if we imagine where the Earth is displayed in this diagram as being a nodal point, a vortex of magnetism that doesn't allow all the full range of radiation to arrive at the moon, only what Bob was describing as the longest wavelength, only the red wavelength to arrive. So we get
Correct.
that reddening effect.
Correct. And Bob is going to, I mean, Bob has had to explain the wavelengths and how everything works to me so many times, so he'd be a much better explainer on that. But I think, are we happy? I mean, do we have questions, or can I put Bob back on?
Yeah, that was cool.
All right.
Cool.
You guys, that was fun. Thank you.
Yeah.
To show this is if you actually take a ball and shine a light on it, even though we're not saying that the sun is being shined on by here, we think it's an irradiation that is fluorescing the moon. So it is a fluorescent, not a visible light effect, but it's a fluorescent radiation effect that will work in the gemstones or in the minerals that we're working with. And so it's basically fluorescing a white during it when you see the full moon over here. And it's only the part of the moon that's exposed. That's the, yeah, I really like this when it's clear. Okay.
Yeah.
So we're all underneath. This is just the North Star or something in the middle. It's not here in the middle of it, it's underneath. Okay. And basically, if you look at these angles here and place it, what I have is in a new moon, what happens is the sun is here and the moon is in the sky with it, like the time and date pictures and that. It's doing it. So if you look at the sun every day goes around one time, and the moon does not go as quickly as the sun. It lags behind. So look at the moon. Here's the moon down here. And look at the moon in time as during the new moon, it is right here. 7 days later, on a half moon, it's here. Your sun is staying in this same position, and on this model, it's just, again, showing you how a month works. A full moon, the moon is up here. Your half moon, again, it's over here. And you're back to a new moon. If you look at the altitude, how the sun and the moon are getting lower in the model, and I'm going to do a camera in a minute,